I'm Stacy Roberts, and I teach 4th grade at Amherst Elementary School. I'm also a math demonstration classroom for Knox County Schools. Today, we'll be looking at 2 standards. The first one is relate decimals and fractions. You'll read and write decimal notation for fractions with denominators of 10 or 100. And you'll locate these decimals on a number line. Comparing decimals. Compare 2 decimals to hundreds by reasoning about their size. Recognize that their comparisons are valid only when the 2 decimals refer to the same whole. Use the symbols greater than, less than, and equal to show the relationship and justify your reasoning. So let's start out by looking at some vocabulary words. Fraction, a number that names equal parts of a whole. A fraction names a point on the number line. This is an example of what a fraction looks like and how to identify it on the number line. Decimal, a number containing a decimal point that separates a whole from fractional place values. In 4th grade, we only deal with tenths and hundredths. And here's an example of where the tenths and the hundredths are located. Decimal point, the dot used in a decimal that separates the ones place from the tenths place. And we often read it as and. For example, 13 and 95 hundredths. Equivalent fractions. 2 or more fractions that name the same part of a whole or the same point on a number line. 4/8 is equivalent to 8/16 because we multiplied the numerator and the denominator by 2. Throughout today's lesson, you'll hear me mention the inverse operation, and that is just meaning that it's an operation that will undo what you just did to a problem. So if you're dividing, to undo that, you will multiply. Or the opposite, meaning if you multiply, you will undo it with division. Same as adding and subtracting. So here's an example. 2 times 3 equals 6, which is multiplying. So the inverse of multiplication is division. It will undo what we just did. So 6 divided by 2 equals 3. Now let's look at the first example on your worksheet. It's wanting us to write decimals that are equivalent to 7/10 and 70 hundredths. They've given us a visual model to show 7/10 and 70 hundredths. And visually they do look equal, like they cover up the same amount of space. But here in a moment, I will show you how to prove equivalent fractions to match the models, as well as using a place value chart can help us identify equivalent fractions. So if you fill in 0 and 7/10, you don't have to put anything in the hundreds because there's nothing there, but you can. And that's why it will look 2 different ways sometimes. It'll have the 0 or it won't, but it's equivalent to 70 hundredths because the 0 is in the hundreds place and the 7 still has the value as it is in the tenths place. So now let's talk more about proving how to get equivalent fractions. When proving that 7/10 is equivalent to 70 hundredths, you want to set your problem up just like this. And you can start with by looking at the numerator or the denominator. I just always look at the denominator, and I'm going to think about how many times 10 can go into 100. And I know that is 10 times. And then if you've multiplied the bottom by 10, you must multiply the numerator by 10. So 7 times 10 is 70 hundredths. That proves how you have equivalent fractions. Now to give you an example of when you would divide fractions and do the inverse, let's look at the same problem. So 70 hundredths, the inverse of what you did up top would be division. And instead of multiplying by 10, we're going to divide by 10. 100 divided by 10 is 10. If I do it to the bottom, I can do it to the top. 70 divided by 10 is 7. Again, you can start with numerator or denominator. It does not matter. Now, while you're also doing this activity, you're going to see where it asks you to write a decimal that's equivalent to a fraction. So looking at 2500ths here, let's look at what the equivalent decimal would be. Now, if you forget where your place values are, refer back to the place value chart that we reviewed in your example. So looking at this, I know I have no whole numbers, and is with a decimal, and then I'm going to write 25. And I'm going to read that as 0 and 2500ths. And the reason I read it as the place value of hundreds is because the 5 is sitting in the hundreds place value. Now, when you read the fraction and the decimal, they should read the same. So let's read them together, starting with the fraction. 2500ths equals 0 and 2500ths. So that way they are the same. Now, let's look at 5/10. Let's write the decimal equivalent to this fraction. If you said 0 and 5/10, and you want it to look like that, that's correct, because the 5 is sitting in the tenths place value. And we didn't put anything in the hundreds place value because there's nothing there. However, as we discussed in our example, you could have written the decimal like this, because that 5 is still sitting in the tenth spot and the 0 is still representing nothing in the hundred spot. However, you just read it a little bit differently. 0 and 50/100ths, but they are equivalent to 0 and 5/10. Now we're going to look at the example of comparing fractions. Now in this next example, we're comparing fractions and putting them on number lines. So the example shows 9/10 compared to 5/10. It shows you a model so you can visually see that 9/10 is greater than 5/10. But you also need to be able to reason, to think, to talk, and to write through how you know 9/10 is greater than 5/10. So we're going to look at it in two different ways other than the visual model. So you know that your whole pieces have to be the same size. And what that means is they have to have the same denominator. And in this case, 9/10 and 5/10 have the same tenth denominator. But it also means that if you're given a picture this size and this size, that they are not the same size whole pieces, so they cannot be compared. So not only should they have the same denominator, but they have to be the same size if you're giving a visual model. Now, anytime your denominators are the same, you can compare the numerators just as if they were whole numbers. So 9 is greater than 5 in whole numbers, so 9/10 is greater than 5/10. Now to display that on a number line, since you're dealing with the denominator of 10, your number line needs to be split up into tenths. So I also tell my students to label the one whole as 10/10. And I know the halfway mark between 0 and 10/10 is 5/10. So using that benchmark fraction of 1/2, I can go ahead and label 5/10 and then mark my spot on my number line. So then I can start at 5/10 and count up to 9/10, 6/10, 7/10, 8/10, and 9/10. And I'll mark my spot on my number line of 9/10. And this is another way to prove that 9/10 is greater than 5/10 because it is closer to the whole number of 1. You may also see it listed on your worksheet as 9/10 is greater than 1/2. And that's because they're referring to the benchmark fraction of a half, which is equivalent to 5/10. But they mean the same. And that is how you can use different strategies to compare fractions. In our last example, it asks us to solve a problem comparing tenths and hundredths decimals. So the example reads, Colin lives 0 and 6/10 mile from school and 0 and 65/100 mile from the park. which place is closer to home. The first thing it says to do is to write each decimal as an equivalent fraction. So I've written down 0 and 6/10. Now, remember back to the first example we worked through. We will write this equivalent fraction. The decimal 6 is now the numerator, and the place value that it's sitting in is its new denominator. So it's sitting in tenths. Okay, now let's look at home. 0 and 65/100ths. We're going to convert it to a fraction. So the numbers are now our numerator. And because the 5 is sitting in the hundredth spot, you read that as 65/100ths. Our denominator is now 100. So you have 65/100ths in fraction form. It then says write the tenths fraction as a hundredths fraction. So here I have 6/10, and I need to write it as a hundredths fraction, meaning an equivalent fraction. So we're going to think about how many times 10 would go into 100, and that would be 10. And if I do it to the bottom, then I need to do it to the top. And now I can say that 6 times 10 is 60. So I know that 60/100ths is equivalent to 6/10. And now I can compare fractions because I have two fractions with the same denominator or the same size whole. And that's the next step that it's telling us to do, is to compare the hundredth fractions. So I'm going to write 60/100ths and then 65/100ths. The good thing about this is once the denominators are the same, you can compare the numerators just as if they're whole numbers. And so you know in the number sense that 65 is greater than 60. So you'll write your greater than sign open to the right. So this will read that 60/100ths is less than 65/100ths, or you can also read it as 65/100ths is greater than 60/100ths. And now you'll continue to answer the questions 1 through 6 using this information to solve the problems. Thank you so much for joining us today in this math lesson on fractions and decimals. I hope this has helped you understand a little bit more about making equivalent fractions and comparing them to help you answer your questions on your worksheet. If you do have questions or need help, you can always reach out to me at stacy.roberts@knoxschools.org. But I really appreciate you spending some time with me today. And on your way out the door, I just want to leave you with a quote. Math gives us hope that every problem has a solution. Thanks so much for tuning in. Bye-bye.